Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study the concept of what are the fundamentals of gears and gate trains. In this session, we are going to learn the classification of gears. So, what is the purpose of the gears and what is the application of gears? Application of gears. The gears or the elements are used to transmit torque from one shaft to another shaft. Is known as gears. Here, in the initial stage of the gears or traces, there is a friction wheels. Figure here indicates the friction wheels. Friction wheels doesn't have any recess or protrude on the surface. So here, consider that though there is no slipping between the disc 1 and disc 2 or friction wheel 1 and friction wheel 2, then the velocity, linear velocity, that is Vp equal to omega 1 R1 that equal to omega 2 R2. So Vp is the constant, then that is what is omega 1, substitute in the place of omega 1 2 pi n1 in the place of omega 1 and omega 2 equal to 2 pi n2. Then the equation becomes 2 pi n1 r1 equal to 2 pi n2 r2. 2 pi get cancelled, then n1 by n2, that n1 by n2 equal to r2 by r1. So where n1 is the velocity, that is angular velocity in revolutions per minute, and what is omega, angular velocity in radians per second, and r1 is the radius of the disc wheel 1 and r2 is the radius of the disc wheel 2. Now the meaning is that here inversely proportional to the velocity, the angular velocity is inversely proportional to the radius of the discs or radius of the friction wheels. But the disadvantage of this friction wheels is that there is chances of slipping. If there is a slipping causes more and more. That's why we have to add, gear is the one by adding the protrude on the surface. Instead of, here the motion takes place from one shaft to another, from one wheel to another wheel, because of due to rolling contact. Okay, instead of, if you want to, by keeping the wheels, so what will happen here? Not only rolling, sliding takes place. So then those wheels are known as gear wheels. So the important is that the contact between the gears or the contact between the two friction wheels is a point contact. So that's why these pairs are considered as higher pairs. What is the lower pair? If the contact between two elements is surface contact or area contact, then those pairs are known as lower pairs. But here the contact between the two gear wheels is a line contact or point contact. That's why these pairs are known as higher pairs. Now, from this equation, that is n1 by n2 equal to r2 by r1. So n1 by n2. So it is inversely proportional to the speed, the angular or the speed of the wheels is inversely proportional to the radius of the wheels. If the radius of the wheel is large, then the speed becomes low. If the radius of the wheel is small, then the speed becomes high. So here we considered this equation by assuming that no slipping of the two surfaces. So this is the kinematic relationship exists for the linear velocity. The linear velocity, that is that Vp equal to r omega. What is that r omega? Omega means 2 pi n. So by substituting in the place of angular velocity in terms of, that is 2 pi n, in the place of omega 1 2 pi n1 and omega 2 2 pi n2, then the relation occurred is that omega 1 by omega 2 equal to n1 by n2 equal to r2 by r1. Now, to transmit definite motion, to transmit a definite motion of one disk to the other, or to prevent a slip between the surfaces, what we have added is projections or recesses on the two disks can be made in order to minimize, in order to avoid the slipping. To prevention of the slipping, we have to add the projections or recesses on the surfaces of the two disks, which can mesh with each other. This leads to the formation of the teeth on the discs, and the motion between the surfaces changes from rolling to sliding. So that wheel, we can see it here. If you see, so in that manner, so another wheel having another teeth, the teeth and mesh each other on the surface. In that manner, it begins another circle. So these two teeth are meshing. These are recesses. These are recesses on the friction wheel that known as a teeth. The gears consists of a teeth to prevent the slipping. Now here, before that, in this figure, the motion takes place from wheel 1 to wheel 2 due to rolling. Now, because of the teeth, it transforms from rolling to sliding. Now, the discs with the teeth are known as gears or gear wheels. Otherwise, without teeth, wheels are known as friction wheels. Friction wheels. Now, here in this gear 1 and gear 2, suppose the wheel 1 and wheel 2, both will rotate in opposite direction. If the wheel 1 is rotating in clockwise, wheel 2 rotates in counterclockwise direction. So in order to transmit the motion or torque from one shaft to another, the wheels, from one shaft to another in opposite direction, then it is joined, the contact between the two wheels are externally. If the same motion is required, then what to do? We have to connect from one wheel to another wheel internally. That is called annulus, internal contact. The outer wheel, whatever the outer wheel rotates, and the inner wheel also rotates. That is the inner contact. So to transmit motion in the same direction, then we have to contact the wheels. That outer wheel is called annular wheel, annulus, annular. Internal wheel is the small wheel, that is called pinion. So from friction wheels to the wheels are transmitted, now it is gears. How it is transmitted? Without teeth, then those wheels are known as friction wheels. With the teeth, the wheels are known as gear wheels or gears. Although large velocity ratios here, what is the velocity ratio? Output velocity by velocity of driven by velocity of the driver. That is the velocity ratio. So this velocity ratio of the driving and the driven members, what is the limited value for this velocity ratios? For spur gear, it is velocity ratio is limited to 6. And for helical gears, it is for spur gears. We will study what is the spur gear. And for helical gears, velocity ratio is 10. For helical gear. And double helical gear, that is called herringbone gears. Herringbone gears. So in order to obtain the large velocity ratio reductions, we have to use intermittent wheels. 2 or more wheels you have to attach from inner wheel to outer wheel. or driving wheel to driven wheel. Now there are various classifications of the wheel. Now here, very important is that these are the based on the axis of the shafts. If there are parallel teeth or parallel axis of the shafts, the gears are classified into spur gears, rack and pinion, helical gears, and double helical or herringbone gears. So these are various types of gears based on the parallel contact or parallel shafts, based on the axis of the shafts. We can see all these axes here are parallel to each other. So the gears here, these are inner contact gears. This is annular wheel. This is annular wheel. Now it is pinion or inner wheel. The direction of rotation of the annular wheel is the same as the direction of the rotation of the inner wheel contact. So it moves in the same direction. The axis of the shafts remains the parallel to each other. That's why it comes under one of the category based on the wheel shape of the teeth. The teeth is the spur gear, that is called spur wheels, spur teeth. That's why it is known as spur gears. So these spur gears having disadvantages, lot of noisy. Okay, let us count here. There are figure A and figure B. In figure A, it is external contact, but line of teeth, the direction of line of contact is a line. Is the line of contact, but here the direction of rotation of one of the wheel is in opposite to the direction of the rotation of another wheel. Both are not same. But these wheels are having type of teeth. It is a straight type of teeth, but parallel to what? Parallel to the axis. These are the teeth, straight type of teeth, parallel to the axis of the wheel or axis of the shaft. Okay, one more important. These are not subjected to axial thrust. Why? Because it is parallel. But normal to the axial thrust, normal to the axial axis, there will be a thrust. That thrust will be occurred more on these wheels, on these teeth. So at higher speeds, it is more noisy. One more important is that at the time of engagement of the two gears, the contact extends across the entire width, okay, on line parallel to the axis of rotation. Okay, what is the axis of rotation? This is the axis of the rotation. These are the teeth. So one more thing is that if you want to transmit the motion in the same direction, that is a figure B indicates inner contact in the same direction. The outer wheel is same as the inner wheel direction of motion. Both are in clockwise direction. But in figure A indicates it is external direction, that is opposite direction. And the tooth on the wheels rotate opposite to it. Is a counterclockwise, one is clockwise. It is clockwise and it is counterclockwise direction. So one more thing, the smaller gear is known as a pinion. Smaller gear is known as pinion, is called as pinion, and a larger wheel is called as a gear. Okay, this is the meaning. Here it is internal meshing, and here in figure A indicates external meshing, and it is internal meshing. Internal meshing transmit the same direction. Both the pinion and gear rotates in the same direction. That is the first under the category of parallel shafts. There is the spur gears. So these are the motions of the spur gears. For further showing that in the external contact, external meshing in opposite direction. Okay, clockwise, and it is anti-clockwise. Here it is inner contact, inner meshing. Both are rotating clockwise direction. The next type of classification of the gear is called spur gears and pinion. Spur rack and pinion. Rack and pinion. The spur rack and pinion. So spur rack is a special gear of a spur gear. Spur rack is a special gear of a spur gear, made of spur gear. Here, which one is the rack? This is a rack. It is a pinion. Rack and pinion. So here, what is the radius of the rack? The radius of the rack is straight, that means infinity. The diameter of the rack is infinite diameter. So the pitch surface, what type of pitch surface it is? The pitch surface is a plane. The spur rack and pinion. Why it is a spur rack and pinion? The spur rack and pinion. The spur rack and pinion converts rotary motion to reciprocatory motion. Converts the rotary motion to reciprocatory motion. The rotary motion of pinion is converted to reciprocatory motion. If it is in clockwise, it moves towards left direction. If it is in counterclockwise, it moves in towards right direction. This combination, when it moves clockwise and anti-clockwise motion, the spur gear moves, the rack moves to and fro motion. So it is a translatory motion. Where it will be used? It is used in a lathe, where in which the rack transmits motion to the saddle. Rack transmits motion to the saddle. So very important here. Why it is a spur rack and pinion? The teeth are straight teeth. Okay, both on the teeth on rack and pinion are straight. Okay, this is the straight teeth. So the diameter of the rack is infinity. So wherever the power or torque to be transmitted from rotary to reciprocatory motion, where we are going to use this rack and pinion mechanism. So the line of contact is the teeth are straightwards. So pinion teeth is parallel to the direction of the axis. Parallel to the axis, and line of contact is straight line. The line of contact is straight line. So this is the spur, rack and pinion. The next classification we are going to see is that here this is animated. We are going to see how it moves. So it is the reciprocatory motion, translatory, and it is rotary motion. Now the next type of under the spur gear, what is under parallel shafts, is helical gears or helical spur gear. So here helical gears means there is some helix angle with some inclination. So one is the driver, another one is also driven. Okay, and it converts both rotary motion, both are in, it is in external meshing, so it will rotate in opposite direction. The driver gear is rotating in opposite direction to the spur pinion, opposite direction to the pinion. Another. So here very important is that when it is rotating, there will be a thrust, axial thrust acts on the teeth, because the teeth are not straight but is inclined. It is inclined, and these two want to meet each other, means for mating mating gears should have same helix angle. Both should have same helix angle. But one thing is that the teeth are in opposite side so that it can meet. If it is like that, exactly it will be another direction, opposite. Okay, and very important is that it is less noisy, having more loading capacity, bare loading capacity, and also low impact stresses will be occurred, and noise also very low in comparison to the spur gears. And one more thing is that the axis of the both gears are parallel to each other. That's why it comes under the category of parallel shafts. So one more thing is that these gears are used, okay, can be operated at One thing is that at higher velocities or at high speeds. At higher velocities or at high speeds. At high speeds. And one more important is that load bearing capacity or load carrying capacity is high. Load carrying capacity is high in comparison to the spur gears. And one more thing is that there is disadvantage of these gears is that end thrust will be high. Action of end thrust, okay, along the gear axis. More end thrust takes place on the teeth. So here the teeth are inclined, not straight horizontal. So the angle of, okay, one more thing, it can be transmitted more torque in comparison to the spur gears. So these are the type of helical gears. So these are the helical gears motion. You can see how it is contact and transmitting the motion. The meshing is external mesh, therefore it will rotate in opposite direction to each other. It's a larger helix angle. The larger helix wheel is called gear and small is called pinion. But the wheels are in exactly mating each other in opposite direction. So it is a meshing. The meshing is that external meshing. It is external meshing. So where we have to use, it will be used, more torque is required and less noisy, and it can be operated at high speeds. And coefficient of friction is high in comparison to spur gears. But disadvantage is that end thrust acts along the axis of the shafts. But the axis of the shafts both are parallel. That's why it comes under the category of parallel shafts. The next one is called double helical or herringbone gears. Yes, double helical, before you have seen single helical. So single helical, no need to pronounce as single helical gear. It is a helical gear. But particularly if you are having a double helical, it is one of the wheel. Okay, this is another. The both, but it comes under the category of parallel shafts. So double helical gear is equivalent to a pair of two wheels, two helical gears, having opposite direction of helical angle, helical teeth. So these two of mating gears, these two are separated by a groove. Run out, okay, a groove. So what will happen in this double helical gear, in order to overtake this end thrust, that disadvantage is there in single helical gear. So in double helical gear, this end thrust will be minimized, reduced, and it are made cancelled completely. The end thrust will be so completely eliminated, which is occurred in the case of single helical gear, whereas in the case of double helical gear, end thrust along the axis, end thrust along the axis becomes zero or nullified. So one more thing is that it can run at high speeds, this double helical gear, with less vibrations, with less noise and vibrations. And the cost of double helical gears are higher in comparison to spur and single helical gear. So in this, some of the teeth are right and some of the teeth are on left direction. So these two meet at common, that is known as apex, but there is no groove in between. So that gear is known as herringbone gear. That is known as a herringbone gear. So these are the meanings of double helical and herringbone gears. So far we covered the first classification of the gears, that is the first classification, that is parallel shaft. What are the parallel shafts? In all the spur gears, spur rack and pinion, helical gears or helical spur gears, or double helical or herringbone gears, the shafts are both driver and driven gears are having parallel to each other. It is not some inclination or perpendicular to each other. So these are parallel. Spur gears more noisy at high speeds, and there is a chances of slipping also here. And whereas rack and pinion, it transmits rotary motion to reciprocatory motion, or it transfers rotary motion to translatory motion, where that type of motion is required. This rack and pinion gears are used. And whereas here helical gears, in this helical gear it is a single helical gear, and both shafts are parallel to each other, and one of the shaft is having in this teeth are in one direction, so having some inclination, helical, with having some inclination, that is called, that angle is known as helical angle or helix angle. So another teeth, that is the pinion gear, opposite wheel or driven wheel, having in opposite direction such a way that it intersect each other. Suppose if you use in the same direction of the teeth, what will happen? The same direction of the teeth means it will not intersect, exactly meshing doesn't take place. So it should be in opposite direction such a way that the meshing takes place. The meshing here, in the case of helical gears and herringbone gears, it is external mesh. It is not internal meshing. We have shown here, we have seen here. But the point is that in order to transmit the motion in the same direction of the both the driver and driven pulleys, we have to use inner contact. That is called annular wheels. So spur gears, we have seen that, as I explained here, this is the both pinion and gear are rotating in the same direction because of inner contact, inner meshing. So it is inner teeth are there on the annular wheel, and pinion is having external outer teeth. So both are contact meshing, that is inner meshing, so that both are having in the same direction of motion. Here it is in clockwise. If you see from top view, both wheels are rotating. Now one more, this is just now as shown, there are different types of gears. This is known as gear train, because number of gears are in contact, it transmitting the power from one gear to another gear. One more thing is that it is like in broad classification we will learn what is the gear trains under the category. It is like, sun and planet gear train. Okay, these are all gear trains, how it is moving you can see. We'll study more and more. Now there is a double helical gears. In this double helical gear, this is double helical means two helical teeth are in opposite direction. It is one shaft. Okay, and this shaft will be in touch with another interaction, another shaft, so transmitting the motion. This double helical gear, double helical gear is costlier in comparison to spur gears and rack and pinion and helical gear, single helical gear, and the design is complex, and we need high skilled worker to fabricate double helical gear in comparison to single helical spur gears. So all these, if the two gear wheels are in external contact, it will rotate in opposite direction, and if there is inner meshing is there, it will rotate in the same direction. And very important is that all these wheels comes under the category of higher pairs category according to kinematics of machines. So when a higher pair is there, this is the point contact or line contact. Okay, and the coefficient of friction is low in comparison to the lower pairs. And one more thing is that these gear wheels, these wheels are having externally teeth, that's why it is called gears. If there is no teeth, then all the gears should be operated under the rolling contact. When there is rolling contact is there at high speeds, there is slipping, chances of slipping, and power loss will be taken place. So in order to avoid the power loss and minimize the friction and maximize the speed, torque transmission, so we have added to the friction wheels the recesses or projections on the friction wheels. Then those wheels are known as gear wheels. So for minimizing, for preventing the slipping. And one more thing is that what is the velocity ratio in terms of the teeth here? So that N2 by N1, that equal to here T1 by T2. Why here the gear ratio, that is N2 by N1, the speed of driver to the speed of the driven equal to speed of the driven to the speed of the driver equal to number of teeth on the driver to the number of teeth on the driven. This is also velocity ratio. So velocity ratio related to the speed here it is. Alright. These are the classification of the gears. First classification, there are various types of classification. The first classification, that is parallel shafts category. What is the parallel shaft? The shafts of driver and driven both are parallel to each other. If it is different, that comes under the category of classification number 2. Okay, we'll study in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.